The comparison of Dirichlet, Robin, and Neumann boundary conditions for 1D steady-state heat transfer demonstrates how the boundary interaction dictates the entire temperature profile inside the material. With one side held at a fixed 100 Celsius, the temperature at the opposite boundary, X equals L, determines the heat flow. The Neumann, insulated, condition imposes zero heat flow, zero temperature gradient, resulting in the highest possible temperature, a uniform 100 Celsius across the wall. The Dirichlet, fixed temperature, condition forces the temperature to a set ambient value, 20 Celsius, representing the maximum possible heat transfer and the steepest linear temperature drop. The Robin, Newton's cooling, condition, which models convection, yields a physically realistic intermediate temperature, 33.33 Celsius, where the heat flow is moderate, proportional to the temperature difference between the wall surface and the ambient air.